my name is Ronen Friedman. I'm working in IBM, and I'm with Ceph for the last 6 years, and been doing Scrub for the last 5 or so, even more, never mind. And for a long time, did most of the work in Scrub. The last year, the EC team has done a lot of work on EC Scrub, which will be part of Tentacle and Forward, and did a good job there. But what I'll be showing here is not related to EC in general. I will be discussing performance, and in performance I mean first the time it takes for multiple scrubs in the cluster to complete, which is what I like to happen. And it turns out that, unfortunately, users prefer client I/O, and we are asked by customers and other users of Ceph how we can improve or minimize the effect of Scrub on client I/O, and effect in means of throughput, both throughput and latencies. Out of the two, the latencies is the harder issue to tackle. Okay, so what I'm going to do is first describe some aspects of the Scrub process in details, possibly more than you want to know, but it will be important to understand the configurations and performance counters I will be showing. I will show how to how to learn the status and the important information about the Scrub, and what controls are available to the operator. Okay, some of the things, especially regarding performance counters, are in flux. In the months preparing this presentation, like the same that happened last year, working on the code and trying to explain it, I'm finding things to fix. So I just merged one change to performance counters. There will be a few more, and they'll probably be not in the first release of Tentacle, but the next point release of Tentacle. Okay, and I was asked to I had planned a few presentations, and I would ask to cram 2 presentations together, so the last 5 minutes will be on scheduling deep scrubs, which is related to what we are discussing here. I'll try to speak faster than I usually do, but I probably just slow down over the time. Let's see if we can, how much we can take of this. Okay. So the story begins with an OSD that finds itself with the ability to start a new scrub, which usually means that it hasn't reached the number of maximum scrubs it is allowed to have concurrently. And then we have, that OSD looks at its queue, which is a new design in Tentacle. There was a presentation in previous Cephalocon what we plan to do. It was implemented more or less as presented. I'll try to say a few words over the presentation about it, but it's not the main issue here. The new Scrub queue is queuing Scrub targets, which is a combination of a named PG, the level, and a few other things. Okay, so in this case, this is the imaginary Scrub queue. You see that 3 targets are ripe for scrubbing at this moment. Ripe, it means that the timer is in the past and there's nothing preventing them from going on. The OSD will simply take the work order that is in the top of the queue. Okay, still easy and nothing, not related to what we're doing here. Okay, so what is the first step? Assuming assuming we are discussing a regular periodic scrub, not something that you started from an operator command. Operator commands skip most of the preliminary steps I'm showing here, since SQUID. But assuming this is a regular periodic scrub, first step is to get or reserve the resources of the replicas. I'm using the word replica as in a general term. I'm referring to EC2. Okay, the shards in EC2. Now, why it is needed? Because we want to limit the effect of the number of concurrent scrubs that are running and the effect on any specific OSD. There is this one configuration item OSD max scrubs that determines how many scrubs an OSD will take part in a specific point of time. And it's counted separately for I am the primary of this PG or I am the replica of this PG. Okay, there are two separate counts. So we are starting, and that's something that started in SQUID. We are sending the request one by one to the OSDs by ascending numerical order of the active set. And there is only one answer that we accept, which is granted, but that granting might take time. Okay? It might be queued. In this scenario, OSD7 is queuing the request. So, how do you know? By the way, there is a configuration OSD scrub disable reservation queuing, because reservation queuing was a new thing in SQUID. I know, and I read some recommendations on the net to enable that. I don't think that's correct. Okay? I'll say a word about it later. But, okay, how can you learn information about what's going on? I stole this from a presentation earlier today from Kleiso, and I like the sentence there, that Ceph already provides sufficient data for quick troubleshooting. The data is there. I will try to show you how to get to it. Okay, and thanks to, I didn't ask permission, so thanks to the original. Okay, so here are two simple commands you probably know. CephPG dump PGs. You can see the green line there. PG2.a is in the scrub scheduling column. It says reserving, and it's waiting for 22 seconds for OSD 0 to grant its resources. Okay, and by the way, OSD 0 will be the first out of the two that will be required to grant permission. Why two? Because this is a replicas we pull. And if you want to know why you're queued and why no response, you have another command, Ceph tell OSD, dump scrub reservations, and I cut it to the specific OSD 0. And you can see here, oh, sorry, I'm not using that. You can see here that there is one scrub in progress in this OSD, and there is only one allowed, and that's why there is a large queue here. This is, of course, contrived. I simply reduced the number there, but there is a large queue of OSDs waiting to be allowed to continue here. So these two commands allow you to know what's really going on. It might help you, for example, in case you have an OSD which is in trouble and is slow to respond, slow to complete the work. It happens usually because of hardware or networking issues. Okay. Another thing that is available is the counter dump that was mentioned just in previous presentation in the other room. There's a lot of information that can be gleaned from the counters, and there are many new counters that for scrub, but they are new, and they're in a bit of a flux yet because we had troubles with extracting labeled counters from the OSD. It was something new. So we have both, for Scrub, we have both labeled and unlabeled counters. And the names are still, might change a bit. So be ready for that. And you can see here that there is a lot of information. I don't know if you can see, but I hope you can see that there's a lot of information here. How many scrubs started, how many, in this case, how many replicated scrubs started, how many EC scrubs started, a lot of data, how many failed. You can see it all here. This is the main source of information to understand what's going on. Okay, let's go on. So, if you did set the reservation queuing, then an OSD that is busy will just send a reject. This is the old way before, until WIF, I think. If you're setting this, you'll see, and that's just a note, you'll see in the logs many failed attempts to start a scrub, which is confusing. I know because I'm handling a client request for a client describing this as a bug. No, this is what happened here. The other thing is that if you have, especially in EC pools, because EC pools have many replicas per PG, if you have EC pools and a busy cluster, the cluster will waste a lot of time just trying and retrying those requests. I don't recommend setting this on. I know some users do. Okay. So, preliminary and easy performance-wise part passed. And we have the resources. And now, the main body of Scrub starts, and the main body of Scrubs is chunk by chunk. A chunk is simply a range, and half-open range of elements. And the way it's done, the primary is looping, simply looping over all the elements from the beginning to the end, starting with a slip, with asterisks about it, then selecting the next n objects. We see the n is important, selecting the next n objects, telling all other replicas what is the range that is now being handled, and then everyone, primary and replicas, they are all creating the scrub map, which is simply creating a table for all objects of all the data that we need to make sure that the information is correct in the disks. Okay? So, this is the main loop. If the slipping here is only effective if you are not using the mclock scheduler, remember this, because people are playing with the sleep times while using the mclock, and it does nothing. If you're using the mclock, we are counting on the scheduler, the main scheduler, to be the one that limits the resources used by Scrub. And this is the best way to do things. Otherwise, you have to play with various configuration options just to get to the mix you want between client I/O and the Scrub operations. The new scheduler gives you a way to do it directly. Say how much of the resources you want to give to the scheduler, to the Scrub. Okay, so what is the size of the chunk? There are two parameters, configuration parameters, OSD Scrub chunk max and another one for the shallow scrubs. The numbers were vastly increased in Squid, I think, after testing those. There is there is an effect, there is a large performance effect to the number here. And this is important. This is why I'm specifying this. For example, suppose you do use the old scheduler. You have a 1 million objects PG. You have a normal, let's say, a deep scrub of a chunk of 25 objects, and you insert 1 second between every 40 objects in a 1 million PGs, you might wait a long time for the scrub to complete. Okay? More than that, usually things happen during that time and the scrub restarts. For example, an OSD is down, OSD is up, or whatever. So be careful at, if you're setting a sleep time, which I really do not recommend, I'm using it for tests, but if you're doing it, think about, don't do it if in a large PG. It won't work. It would never terminate. Okay. Now, there is a comment here that the chunk size is this, unless there is a preemption. We'll talk about preemption shortly. Each preemption halves the number until we get to min, and this was the slide, and then it turned out it was a lie because there was a bug in the code, and we never stopped at min. Okay? There is a fix for that just in main, and I'll backport it to Tentacle when we finish the conference. So this is, remember those parameters. Usually, you might want to have the min size not far away from the half of the max size, or not far away from the max itself. Okay. But okay, so let's continue. We have a chunk size, and we have selected a chunk. There is a new graphics here, so let's see. So we won't start scrubbing the chunk until it is quiesced. Okay? If there are any ongoing I/O operations, write operations, for any of the objects in this chunk, we'll wait for them to continue. That's okay? Okay. But what if we are waiting for a long time? This will never happen in normal operation. And I/O should never take long enough for the scrub mechanism to notice that it's blocking on it. I personally saw it happening in case of network problems and disk problems. And once, when there were bugs in the write path of Ceph, which I didn't encounter lately. Things are pretty clean today. But just for you to know, there is a configuration blocked scrub grace period. Once this grace period is passed, you'll see a cluster log, which is a hint that something bad is happening. Okay? And if you miss the cluster log, there are some counters. The good counter is chunk selected. Okay, this is the number of chunks selected. The chunk busy is okay because we might be waiting for an I/O to complete. But if you get the locked objects, that's a problem. Not in first tentacle because locked objects didn't count correctly. Another bug that was fixed and merged yesterday. Okay, so remember this. But assuming everything happens as it usually happens, and the chunk is free, and we are continuing. What happens if there is incoming op that should affect the region that we are currently working on? Remember, we have the chunk. A chunk is just a start point and after the end point. Okay? And I want to emphasize this. Scrub doesn't lock the objects in a regular sense, but it does interfere in access to the objects in this region, in the chunk, in the active chunk. And what it does is this. If the client write-up arrives, the scrubbing is preempted. Scrub stops, the write operation continues, and the scrub restarts for that chunk, but with the chunk size halved. And this happened up to max OSD scrub max preemptions. The logic here is debatable because we continue, the PG will continue with this reduced scrub size. The basic reasoning was that if you are so busy that writes arrive on the specific PG that you are scrubbing, you might want to reduce scrub effectiveness and the effect it has on the rest of the system. But on the other hand, it means that if you had those 1 million objects, that 1 million object PG, and you had encountered an overlapping write twice, your scrub size will be so much minimized that it will take forever to complete. I will raise the idea of removing that in logic, but it's there from many years, for more than 10 years. So I'm not, it's something that needs to be debated. So, counters. The number of preemptions. You have a counter for write blocked by scrub. And you have new counters, scrub IO intersects and IO blocked. These will be in the next tentacle release. The replicated or easy, yeah? We have both sets. Configs. The only config here is the OSD scrub max preemption and the two min parameters which limit the effect of preemptions which you might want to change. Okay. So now, like I said, this is where the bulk of the work is done. The actual creation of the scrub map. This is where the I/O is done, which is what usually is meaningful. So, all involved OSDs now perform I/O intensive scan. If this is a deep scrub, they are reading every piece of data. Okay, the metadata is read anyway, shallow scrub or deep scrub. But here, everyone is involved is reading all the data and all the OMAP data and calculating CRCs, which are sent back and compared in the primary. So, where does it come in? How can you affect and how does this affect performance? These are some details that are the main part of the presentation. So this is the part that is the most meaningful in what I'm saying. Okay? So what happens here in details? Now we are inside one OSD. And this is just a schematics to show you what are the main operations that are required to create this scrub map. So there is an initial step, unrelated. I'll say a word about it in a second. There is and then we are listing all the objects, each OSD, sorry, in its copy of or each shard of the PG in this range, lists all the objects from OXDB, and then performs information gathering on each of the objects in the loop. The object start, the X attributes, the OMAP, and the data. That's a lot of work. Now, nominally, this is the operation performed here, which is scrubbing or collecting the data of a chunk of a list of objects, 25, 10, whatever, of the list of objects is one PG operation. Internally, it means that it is started, the PG is locked, continues and ends, and the PG is released. So this affects latency, theoretically, because if you have any other I/O, of course, that reached the same PG, it will block until we are finished. It doesn't matter if it's not the same objects. The same objects will stop the process. But it does, well, actually, it won't stop the loop, never mind. It doesn't matter that it's not related to the chunk, but it is, and does have effect on latency. Remember that. Now, in real life, this is not one atomic operation, and that's important. There are some yield points where usually the PG will give control back. We'll unlock, we'll requeue the scrubber, and something else can happen. So let's talk about what can happen here. The first one is just a side note. Many years ago, someone piggybacked the scrubber operation to do some house cleaning, internal house cleaning on those objects, which makes sense. Scrubber is a good point to do house cleaning for many things, but the problem is, for some reason, in the end of this step, it was an automatic yield point, a rescheduling of the PG. Now, I now have a PR. I don't remember if it was merged, but if not, it will be merged next week, that avoids the automatic rescheduling, because it costs time for no reason. It will only perform this rescheduling if there was really work done during this unrelated job. Okay? So this is why I'm mentioning it. Anytime during this phase when there was, apart from this point, when there is, where the scrubber relinquishes the PG and reschedules itself, you'll see in the logs, in progress. This is a hint that it happens. If you want to know if that happened, this is one way to do it. Many in progress means that you might check the other data that I'll show in a minute. Okay. The next yield point is here. OMAP, the creation of CRC for the OMAP entries. OMAP entries might be large. And we are limiting ourselves to OSD deep scrub keys. Currently, it's a lot, 1,000. Keys read before we will do a rescheduling. Relinquish the PG, allow other operation I/O to access the PG, and requeued ourselves in the OSD, which might take time. Okay? There is a counter here, scrub OMAP get count. And if you want to know how many times, just to get a feel, how many times we had to overstep this value, there is another counter, scrub OMAP get header count, which is in the beginning of this step, happens always only once for OMAP. If they are not the same, it means that you had a few rounds of going over the OMAP entries. There are clients that hold, I know cases of objects that are almost empty and everything is in the OMAP. So you will encounter this, and it will affect the time Scrub takes. Okay. And then we come to the main point of the work, which is reading the data. The data is done in strides. And the parameter is OSD deep scrub stride. What time is it? Okay, wow. The parameter is deep scrub strides, and the bytes, wow, I thought I had much more time. Okay, I try to speak much faster. The value currently is small. I discussed this with a few people in the conference. For EC, I'm not an expert, but it was suggested that it should be doubled for EC, and it should be more than doubled for a replicated pool. Okay? Because it means that every 4K, if you have a 4 megabyte object, will be in replicated pool, will be read in 8. Because 8 rescheduling. Rescheduling means messages, a lot of I/O overhead in the OSD. The number probably is too low. Okay. Now, this is not my knowledge area, but I was provided with this table. If you're using the mClock scheduler, the mClock scheduler will tell you, will determine how much resources are dedicated to the scrub. It's fantastic in enabling you to do very precise control over the scrub effect. But notice that neither of the two default or prepared schedules leave any time set aside for scrub. So if for any reason you have a cluster where you want to set aside time, and I would give it more than half, but you should create a new table. It's easy, and set the numbers here to something other than min. Okay? This is important because we did have clients that encountered problems with scrub and the MQ scheduler. And thanks for providing the data. Now, there is one comment here which is important. The way the MQ scheduler calculates the cost of scrub is dependent on the chunk size. So if you increase the chunk size, you improve scrub performance. You perform it with less overhead, but make sure you don't create a situation where scrub is so penalized that it doesn't run because of the MQ scheduler. Okay. I'm skipping, well, just one word. I'm not saying a lot of it, but remember there is one more relevant, or two more relevant configuration items, the priority of the scrub internal messaging. Some older versions had those set to high. It was fixed, I think, already in RIF, but maybe just in Squid. I can't remember now. If you have a problem with client latencies, check these two. Okay. So now the other presentation, which is related, I was asked to combine. One of the, like I said, I don't have time to discuss the main changes to scrub scheduling in Tentacle, which are huge, but I will just mention that, like I said, we have decoupled the scheduling of the shallow and the deep scrubs. This required changes to things like how data is reported, how scrub results are stored internally in the RocksDB. There were some issues to fix, but now we can do it, which allowed us to schedule the deep and the shallow scrubs separately for each PG. There are almost no interaction now, apart from the obvious fact that if you just deep scrubbed PG, it means that you, from scheduling perspective, you also shallow scrubbed it, of course. Apart from that, they are different, and that allowed us, I'm skipping things that you might see later, you can just take a look later in the full presentation. That allowed us to create a more reasonable, user-controllable scheduling of the deep scrubs. I don't have time to go over how it was before, but it was strange. And now I hope it makes more sense. There are limits to what I could change because there is existing law and existing information, but I did what I could get away with. So now, the basic idea is that for deep scrubs, you as an operator sets two things. One is the desired interval. This is what used to be the week or the month or whatever. This is how frequent do you wish deep scrubs to be performed. And remember, deep scrubs are not just for bugs, they are for bugs, they do catch bugs, but they also for bit rots on whatever disk you have. It's a lesser problem in newer disks, but it might be a problem in older. And so setting this was never enough. This is why we had such a complex system before. The problem is that you want to spread things, because when a client is started, you don't want to create a thundering herd just after that period. So now what we are doing, you have another parameter, the OSD deep scrub interval CV. CV is the, how is it called? Coefficient of variation, which means the SD in terms of the value. It's a part of the value, okay? We will schedule the next deep scrub within 2 standard deviation of the, as defined by this, 2 standard deviations around what you wanted. Okay, in normal distribution. Now, we always also change the way, when there is a health warning. The health warning, the parameter is there. It wasn't changed by itself, but the cluster health warning will be from this point, the desired interval times the deep scrub ratio. Okay, the parameter itself didn't change. I think it's 3/4 the value, 0.75. It didn't change, but what it affects, where it starts, just changed a bit. After that point, you have a cluster health warning. Before that, in the previous versions, we had here some intermediary steps where it was late, but not that late. That was removed. Okay? And just to remind you, the shallow scrubs I couldn't touch, but at least now they are not turned into deep scrubs on the way like it used to be. Shallow scrubs are shallow scrubs. And for them you have a mean interval and a interval randomization ratio, and we are randomizing from the mean to mean plus that ratio. And again, some changes to the what is a health problem. Okay? So, questions? Thanks.